So in this lesson we will discuss about normal distribution. Normal distribution is basically a proper term for probability bell curve. So it is a proper term for probability bell curve. In normal distribution, mean is 0 and standard deviation is 1. So in normal distribution, we will have a probability bell curve where the mean, median and mode, they all lie at the center. They all will be lying at the center and the standard deviation would be equals to 1. In normal distribution, this is our bell-shaped curve. This is our bell-shaped curve. In its center, there is mean, median, mode. They all equals to 0. So in the center would be mean, and these are the tails which will touch infinity. So normal distribution, in normal distribution we have this bell-shaped curve where the tail will touches the infinity, and mean, median and mode, they all will lie at the center and the value would be equals to 0, and the standard deviation of here would be equals to 1. If you talk about this whole area is equals to 1, and by mean of this center division we will divide this area. Half of the area would be equals to 0.5 and this half would be equals to 0.5. So in normal distribution we will have this bell-shaped probability curve where the tail will touch the infinity. The standard deviation would be equals to 1 and the mean, median and mode, they lie at the center. The formula which we are going to normal distribution is Z is equals to x minus mu divided by sigma. Here x would be the required value. This symbol of mu represent mean and this sigma over here is standard deviation. Now we will solve different cases and we will use this formula into our cases. So in this first case we are going to find the value of z where z is greater than the negative value and is less than the positive value. So the scenario which is given to us is a hospital records the weight of every newborn child where the mean is 2.9 kg and standard deviation is 0.45. Now what we have to find is the percentage of newborn who weigh between 1.8 kg and 4 kg. So first of all we will write the data which is provided in this scenario. We have mean value which is 2.9 kg. We have a standard deviation 0.45 and we have to find the value which is between 1.8 kg and 4 kg. So we will find the two value of z. First of all we will use the formula z is equals to x minus mu divided by sigma. The x is this value and mean is the value which is given in scenario and standard deviation is also given in this scenario. So first of all we will find z1. Z1 is equals to x minus mu divided by standard deviation. Putting the value x, the value of the first value which is given 1.8 minus the value of mu 2.9 divided by standard deviation which is 0.45. So the value of z1 is minus 2.4. Now same like we will find the value of z2. X minus mu divided by standard deviation. Putting the value, the second value x4 minus mean 2.9 divided by standard deviation which is 0.45. So the value of z2 would be plus 2.4. Here the negative mark, the negative sign indicate the direction. It doesn't mean that the area is actually in negative. So it is basically simplifying the direction, that it is in negative direction minus 2.4, and this positive indicate that it is in positive direction. So the scenario, what actually required in this scenario was that we have to find the percentage of newborn who weighed between 1.8 and 4 kg. So we have to find the weight of newborn between Z1 and Z2. So we can write this minus 2.4. So according to the scenario, the value of Z, which is greater than minus 2.4 and less than 2.4. We have to put the value of minus 2.4, and this value would be given to us, and we can also find it from the graph. So we will put the value of minus 2.4 and 2.4. Minus 2.4 value is 0.4918. Z value, which is greater than and less than 2.4, we will put the value of positive 2.4, which is same 0.4918. So these value would be given to us. Either it would be provided in the scenario, or we can find this value from the graph. So when you will so a graph would be simply like in this way. So 0 would be mentioned over here and the points would be mentioned like 0, 0.1, 0.2, 0.3, and like you would have to see you have to find this value minus 2.4, and in the value of Z this value would be given 0.4918. So from the graph we have taken this value 0.4918. So we can write this equation as minus 2.4, the value of Z which is greater than minus 2.4 and less than 2.4. Now what next step is that we have to find the value of minus 2.4 from the graph. Either it would be given in the graph or it would be given in the question. So if it's not given in the question, you can consult the graph. So simply the graph is very easy to see. The graph would be like this. Some values would be mentioned over here like 0, so on, minus 2.4. So the value of positive would be equal to negative. Okay? So like 2.4, it would be mentioned in the graph and you would see the value 2.4 in zeros, it would be 0.4918. So we will take the value of 2.4 from the graph. We will consult the graph 2.4 and its value. We will put the value. So if it's negative, we will put a mark of negative. So negative 4, negative point. Now we will put the value 2.4 from the graph 0.4918. And the value of 2.4, 0.4918 plus 4918. We will add these both value and our answer would be 0.9836. So the question which was required was the percentage of newborn who weigh between 1 and 4 kg. So we have find the value between Z1 and Z2, which is this, and now we have to find the percentage. So obviously we will multiply it with 100 and we will get our required percentage, which is 98.36. So we can say that 98.36 newborn are those who weighed between 1.8 and 4 kg. Now how to represent this equation in bell curve? So this is our middle line. This side would indicate the negative region and this side would indicate the positive region. So we were supposed to find the area between negative 2.4 and positive 2.4. So we were supposed to find this expected area, which we have found through our equations. Now in case 2, we have to find the value of Z where Z is less than minus A, which means that Z is less than the negative value. So what is the question to scenario which is given is the percentage of newborn who weight under 2.1 kg when mu is 2.9 and standard deviation is 0.45. So simply first of all we will write our equation where Z is equals to x minus mu divided by standard deviation. Now we will put the values. X is our required value and our required value is 2.1 kg. We are supposed to find the percentage of newborn who weight under this required value 2.1 kg. So putting the value in the equation, 2.1 minus this mu, this is 2.9, divided by standard deviations, which is 0.45. Our answer would be z is equals to negative 1.78, which means that z is, now we will represent this value in our bell-shaped curve. So this is our bell-shaped curve. So this whole area of this bell curve is 1, which means that half of the part would be 0.5 and this half part would be 0.5. According to the equation, we have to find the value of z, which is less than minus a. So minus a value we have find, which is 1.78. 1.78, we have to find the value which is less than this value. So we have to find this whole area, which means that we have to skip this area. The value of this half side 0.5, and from this 0.5 we will minus this area, and we can have this value 1.78 we have, which is given, which is 0.46 minus 0.462. So from 0.5 we will minus this area, so that we can get the value, our required value, which is less than this z value. So when we will minus this, we will have 0.0375 required in the question, the percentage of newborn. So for percentage we will multiply it with 100 and our answer would be 3.75%. So in case 3, we have to find the probability where the value of z would be greater than a, positive a. So we will find the probability which would be greater than a. So what is given in the equation, the scenario is the height of a joy at a particular age follows a normal distribution where the value of mean is 150.3 cm, standard deviation is 5.0 cm. What we are supposed to find? Find probability of height greater than 160 centimeter. So we have to find the probability greater than 160 centimeter. So if you draw this bell curve, 160 centimeter is in positive, which means let's suppose it's lie over here 160 centimeter. We have to find probability which is greater than this. First of all, we will find the value of z. Let's find first the value of z. We will write the formula. Z is equals to x minus mu divided by standard deviation. Putting the values, x, which is the required value, and this is given in our question, 160 minus the value of mean, which is 150.3 centimeter, divided by standard deviation, which is 5.0. So solving this, our answer would be 1.94. 1.94. So you can also write this instead of 160 centimeter, you can write 1.94. 1.94. So now we are supposed to find the probability which is greater than 1.94. So how you can find this whole area? You can find this whole area same like the previous equation. You will put the value of this half side, which is 0.5, and from 0.5 you will minus this area. So from 0.5, when you will exclude this area, you will get the probability which would be greater than 1.94. So 0.5 minus value of 1.94, which is 0.3621. 0.3621. As we have discussed earlier, that the value would be given either in question, as it is given in this question, either you can find this value 1.94 from the graph. So 0.5 minus 0.3621, it would be equals to 0.1379 centimeter. So we can say that the probability of height greater than 1.94 is 0.1379 centimeters. So in case 4, we have given the value of z, the probability of z, which would be greater than minus a. So what is the question? That the length of a patient's stay in a hospital follows a normal distribution with a mean of 8 days and a standard deviation 2. Find patient stay more than 5 days. We will use the formula z is equals to x minus mu divided by standard deviation. Putting the values into our equation, x, which is the required value, which is 5, minus mu 8 divided by standard deviation 2. Solving this, we will get minus 1.5. Now according to bell curve, if we draw a probability bell curve, minus 1.5, as the sign indicates that this would lie on the left side, minus 1.5. So according to the question, we have to find patient stay more than 5 days. And when we solve this 5 day, when we put this value into our z equation, we have find the value which is 1.5. So we have to find the value of z which is greater than 1.5. So we have to find probability which would be greater than 1.5. It's not less than, it is greater than this, which means we have to find this whole area and this whole area. And as we have discussed earlier, this half area is 0.5 and this area we can get from graph, either this would be given in the question. So 1.5, the value is given 0.4332. So to find the value of z greater than, value of this z greater than 1.5, what we will do? We will 0.5, we will add this value 0.5 plus the value of 1.5, which is 0.4332 is equals to 0.9332. So this would be equals to 0.9332. So if in the scenario they ask about the percentage, which is not mentioned over here, but if they ask that in percentage how many patients are going to stay more than 5 days, so we will multiply 100 with this solved value. So in that case we will get 93.32%. So case 5 is a continuation of our previous case, case 4. This the scenario in this case is the value of z which is less than the positive a. So in this we will find the area which would be less than the positive a. So what is given in this question is to find the stay of the patients less than 10 days. So we will find the stay of the patient less than 10 days in percent. We will put the value z is equals to x minus mu divided by standard deviation. X, the value is 10, minus value of mu 8 divided by standard deviation 2. Our answer would be plus 1. So in probability bell curve, plus 1, this is 1. We have to find the value of a less than this a, which means we have to find this whole area and this area. So how we are going to do this? We know that the half of this area is equals to 0.5, and in 0.5 we will add from 0 to the 1 value, and this value would be given in graph either in the question, and the value of 1 is given 0.3413. So what we will do, 0.5 this half value plus we will add this value. The value is given, this is 0.3413, and this is equals to 0.8413. In percentage if we do, we will multiply it in 100. So we will get our percentage which is 84.13%. Case 6. In case 6 we have to find, same like the previous question, we have to find the patient stay, and here the data would be 9 days and 12 days. So we have to find patient stay between 9 day and 12 day. value of mu is given 8, standard deviation is 2. So putting the value z1, as we have given 2 values, so we have to find 2z. So z1, in z1 we will put our first value, which is 9, minus, so first we will write the question, z is equals to x minus mu divided by standard deviation. z1 we will write the value of our first x, which is 9. So in 9 minus 8 divided by standard deviation 2, this is equals to 0.5. Same like value of z, x minus mu divided by standard deviation. This is equals to, putting the values, the second one 12 minus mu 8 divided by standard deviation 2 equals to 2. So we have z1 value 0.5 and z2 value, which is 2. So if you draw this bell-shaped curve, 0.5, 0.5 and this 2, 2. So what we are supposed to find, we have to find the probability between 9 and 12, which means between this 2 and 0.5. So we have to find the area which would be in between 0.5 and 2. Here the scenario is different from our previous examples. In this we have to find the area, the probability between these two different numbers. So what we will do, we will have the value of 2 from 0 to 2, which would be given in the graph or in the question. So this is given 2, the value of 2, which is 0.4772, and from this greater value 2, 0 to 2, this whole greater area, from the larger area we will minus the less value, we will minus this 0.5 area, this area. So from this area we will minus this 0.5 area. So we will have, we put the value of 2, which is 0.4772. From 0.4772 we will minus the value of 0.5, which is 0.1915. So when we minus this, we will get our value, which is 0.2857. So in percentage we will multiply it by 100. Our percentage would be 28.6%. So we can say the patient stay value between 9 and 12 days would be 28.6.